So, good, good morning, all. Very happy to see a lot of faculty members joining online for this faculty development program on an amazing tool which the FOSSI team has developed, the Arduino on Cloud platform. So, I welcome you all on behalf of the FOSSI and the spoken tutorial projects to this FTP program. And let me just go through the schedule what we are going to follow today. So first we will have the introduction to Arduino Cloud by now we have to we will share the screen. One second. I think that one. I hope the schedule is visible to you. So first we will have the introduction to Arduino on Cloud by Mr. Rajesh Kushalkar. He is actually the program lead of our hardware initiatives under FOSSI. And he also has a team, Pratik Nemane and Pratik Bhosale. They will also be assisting him in this today's session. And we also have conducted a lot of workshops in various colleges across India. So we have invited some of the faculty members to share their experience and what are the takeaways which they received from this particular cloud platform. So we have invited them also to share their experiences. And after that, we will go to the actual main spotlight of this today's program. That is a hands-on session and the little bit of experiences, how you can use it in your curriculum and in your classes. That is Arduino on Cloud. We will have an hands-on session. And after that, our PI, Professor Kannan, will be talking about FOSSI and how we are going around in promoting free and open source software across various institutions in India. He will talk about the projects. And later we have Ms. Akanksha Saini, National Coordinator of the Spoken Tutorial Project training team, addressing the gathering. And later we will take all the queries and any suggestions which the faculty members may have for the Arduino team. Then we will have that session, and finally we will wrap up with a vote of thanks. So let me just invite Mr. Rajesh Kushalkar to take over and continue with the next session. And once again, I welcome you all to this session. Thank you.
Thank you, Vishal, for the session. Good morning, all. Just hold on, let me adjust the things here.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, all. So, thanks for participating in such a big crowd for this Arduino on Cloud event. So, the topic is connect, simulate, and innovate with Arduino on Cloud.
Rajesh sir, sorry to interrupt. Hello.
I'll just brief you about the Arduino and Cloud and why this Arduino is important for us, for today's generation students, and how we can take it ahead in our daily projects and mini projects and final year projects for the students. Of course, it's a very nice tool even for the teaching also. So, hello, I am Rajesh Kushalkar. I am basically coordinating the open source hardware at IIT Bombay under the FOSSI project. So I'll just take you in the history side. So we have seen various stages of our industrial revolution. So industry one, so where all the industries were working on the steam power. So with the steam power, all our industries were working, the engines were working and all these things. So but the process after the thing industry one, then the industry two came. Industry two is basically when the electricity was invented and people started using electricity to run their motors and all the thing. And this is how the sorry for the interruption. Hello. So uh, hope my audio is clear.
Yes, Rajesh, it is clear now.
No, because people were some experiencing some echoes and all those things, so that's why I just wanted to know. We are just having some issues. We are just restarting, and we'll just take 2 minutes to join back again. Sorry for the inconvenience.
There is some audio issue. Am I audible?
Yes, madam.
Yeah. So there's some audio issue. So they'll join in some time. Uh, Meanwhile, we can just chat a little bit. How many of you know about Arduino uh, or have gone through Arduino tutorials? Because all of you are from subscribe colleges. So you can just type yes in the chat box. Okay, I can see one yes. Yes, I know about Arduino, something like that. Okay, okay, I can see message coming up. Oh, many of you then. Yeah, so then this session will be very useful because we are going to show you something exciting, that whatever you do experiments on the breadboard, those experiments we are actually going to show you how you can do it on the cloud. Okay, later on you can explore how it will happen. Okay, so it will be a great experience for you all. So yeah, enjoy the session, and we are sorry for this glitch since it is online. So some things needs to be set up. Okay, we lots of yes. Good, good, good.
हेलो हेलो दीपक।
हेलो चेक, कैन यू हियर मी? अभी ठीक
हाँ
है?
हाँ हाँ सही है।
ओके। हेलो
हेलो
चेक। हेलो 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 एक मिनट। हेलो 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 चेक। हेलो 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 माइक टेस्ट। हेलो चेक।
एको आ रहा है दीपक जी, एको इज कमिंग।
हेलो 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 हेलो
हाँ देख ये सुन जरा। हेलो उधर से बंद है। हेलो हेलो वो भी नहीं है, दूसरा है। हेलो हेलो
This
चेक।
is better. This is better.
हेलो आ रहा है दीपक, सही है
हाँ,
बेटा नहीं?
this is better.
हाँ तू सुन ले दीपक, एक बार सुन ले साउंड। हेलो चेक माइक टेस्ट 1 2 3। हेलो चेक। हेलो हेलो चेक माइक टेस्ट। अभी क्लियर है दीपक, आवाज मेरी थोड़ी? प्रदीप सही है, बराबर है ना? हाँ हेलो हेलो चेक। हेलो हाँ
नहीं करता शेयर करना yeah. Sorry for the interruption. So there was some audio issue at our end. Yeah, so okay. Hide. Uh, so good morning all. I'll just start again. Sorry for the glitch from our side. Uh, so today's topic we are going to talk about connect, simulate, and innovate with Arduino on cloud. Hello, I'm Rajesh Kushalkar. I'm coordinating the open source hardware at FOSSI project under at IIT Bombay. So the world has seen the changes from the industry one. So the first revolution which came was the industry one. All the engines and the industries were working on the steam power. So the early industries were working on the steam power. After the invention of electricity, the industry started using electricity, and the things started moving fast, and the production also started moving very fast. And people were able to do multiple jobs at a time. So then came the industry 3 revolution, where a lot of robotics and a lot of electronics came into picture. With this, precision was made. Means there was not much human intervention, and all the jobs and were done by the robots and by the CNC machines majorly. And due to this, precision and quality of the products were increased. And after that, now presently we are in the industry 4 revolution. So in industry 4, the same robots and the same plants and everything can be operated online also. Everything is uh, done through then online features. It is connected to Wi-Fi, and people can just check their production status and all those things. All how much the is running and all that stuff. Actually, it is done in industry 4 majorly. Now, in this particular part, especially if you see the industry 3 and industry 4, there's a lot of electronics was used. And initially, the electronics were very bulky and all this stuff. But as the technology grew, these things started to shrink. The electronics started to shrink, and nowadays you can see the whole TV has become flat. The watches have become very small in the digital format, also mobile phones. So you can see the lot of revolution has come in today's generation. So what is the difference that you see in all the above revolution from industry 1, 2, 3 and 4? It's innovation. Every time there is a new innovation and new thing comes to improve their uh, production, improve the quality. So a lot of things have gone into innovation more. And it's a human tendency that innovation is never going to stop. It's an infinite loop process. The thing is going to continue. Why I talk innovation is an infinite loop and all this thing, because if you just take a very simple example, Edison has invented bulb. Okay, so you see the innovation in the bulb technology. Now what happened? The light technology, the bulb technology has come to now LED. So you see the power consumption has reduced, the size has reduced, the heating or dissipation and all this efficiency has increased and all this stuff. So innovation is a continuous process. So it is never going to end. So we may find the future of industry 4 or something might come in the future also, but this is the thing is going to change. So that's a very small simple example that I just wanted to share that thing with you. So likewise, we have seen there's a various revolution has changed in the education sector also. Now, what happened previously, we used to have, since we are majorly of electronics background students, and so we have seen how we used to do the electronic testing, the labs and all this thing in previous thing, microcontrollers, how the labs were taken and all the stuff. Now all that thing has also shrunk with the easy to program devices and all this stuff. Of course, there was a lot of change in the education sectors also after coming the internet and all this thing. So everybody has experienced it during the COVID time also. The major were online classes, where all the labs were shifted to online versions and all this stuff. So on the same basis, we'll be continuing how we can take the microcontroller, especially the Arduino part, as an online version. So that we'll discuss in the future part, further talk. So in early days, creating such a thing means we require a major skill worker, engineers were required with a lot of finance. Basically, the instruments and all the things were very big. Oscilloscope, you see when as a teacher, teacher, when you are a student, so you see the size of oscilloscope, what used to be there that time now, and what is the scope oscilloscope presently used. Okay, and the features, of course, the features has also added a lot, and lot of wirings, not in a single thing. So lot of issues were there during the early engineering, and there were a lot of financial resources were also required for that thing. But as you know, the internet has come, and with uh, the world of emerging the open source software and hardware, and people have started sharing their thoughts on internet. Yeah, we can make something like that, and people started collaborating, and and the open source community tried to build. So we have seen a lot of things in the open source software. Similarly, there was a lot of good emerge in the open source hardware also. So we see Arduino is one of the perfect platform which was emerged of an open source hardware. So all the designs, everything was open for the community. So people can, the community can do whatever changes they want to and customize as per their requirements. Okay. So what Arduino has given us is a platform where students can do tinkering, start to do their first product project or something like that, because it's a very good hardware platform what the students and many of the industries still uses, and also they uses for the early prototyping. So I generally call it as a chota packet bada dhamaka, but it's a very small pack. It's just less than a credit card size. What you get, it's a compact microcontroller, and a lot of things are available on that particular board. So imagine, because I'll just trying to give you a few examples. Imagine your plant could say that they are thirsty. Now what happened nowadays, not previously, people used to just go, yeah, pour one full jug of water in one plant. Excess of water flows where the plants don't require it also. We are just pouring a lot of water, and wastage of water and all this thing is definitely there. Same thing is there for the agriculture sector also. A lot of water is wasted, which is not required. Okay, many of the things, minerals and all this thing, many times it get washed away also due to this. So if you have some precise thing, okay, I require this much amount of water and this much times of this thing only, so how it can be done? So this is a simple example which I'm just trying to show it, is an Arduino is used to pump a required water. Yeah, power plant is saying, yeah, now my things are over, you can stop the pump. So how this thing can be done? So in many of the, this is a basic example for the agriculture. At home also it can be used. So you have, there are a lot of gadgets which have been invented. Now the air pollution. So now it's a major problem across the country. But what is there inside the air purifier? How it senses the air quality is bad? Okay. So nowadays you have this room air pollution is coming, and how this thing is made. Suppose my room is having air quality is not that good, but actually means what happened, you have this PM 2.5 materials which are there roaming. So how to get that dust and all this thing clear, and you have a fresh air coming out. So these are, there are various sensors built in the device which senses the temperature, the air quality, what kind of gas it is there, what kind of particles, materials which are there. So to take out all the things, so you have a lot of things. So as you see, a lot of electronics also go into this part. If you just try to consider what all things we have, so as we have 5 sensors in our body, so like that, humans has also try to create it all the sensors in the electronic format also. Okay. Now you can have what are the different pressures level available, the biometric pressure, temperatures, everything is going to go. Previously we used to have the thermometer, we used to give us the temperature. Now all the thermometers have been replaced, the mercury has been replaced with the electronic sensors. You can directly get a digit out of it. Same thing is the accelerometer, gyroscopes and all these things. So these are the widely used applications, especially in the drones, the rockets and all those things. But and where they have, in fact, our mobile also has got the accelerometer and gyroscope. Your mobile is really packed with a lot of sensors nowadays. Is a simple example. Everybody uses mobile, and the mobile is heavily packed with almost around 10 to 15 sensors in it. Now we just come to a very simple how this Arduino or these electronic devices can be used for our experiment purpose also. So here we have just tried to demonstrate two simple experiment. Like one side we have shown about the pendulum. So with the pendulum, one can check it how much pendulum it is moving. Previously we used to do with the clock, and with your naked eye. Now this is the pendulum is moving 1, 2, 3, 4, whatever we are trying to calculate it. The damping is happening and it is coming to the rest, and we are just trying to calculate the time with a stopwatch which were available. Now all this thing that Arduino can take care of it with a timer, how much time it took, how many oscillation it made, everything can be done with a simple program using Arduino. Now the second example is a toy car which is just shown. There is one sensor connected at 0 place and other sensor at connected at 20 place. So how much time the toy car took from coming from sensor 1 to sensor 2. So it talks about what is the speed, how much speed it is coming. So nowadays even our traffic police and everybody has taken technology into their hands. They just have the laser gun just pointing at the one of the vehicle that can says, yeah, this car is moving at this particular speed. So yeah, it is a nominal speed, okay. But if he is driving very fast, so challan can be made directly out there. So all that things with the photographs and all this thing it comes in. So today the technology is used each and everywhere, and for that I'll always say this is the very first platform which is used, Arduino. There are various available versions of Arduino available, but to start with, Arduino Uno is one of the best platforms which is available. So what further it can do? There are a lot of examples that is showing in the robotics, in image viewing, then automations, and of course prosthetic legs, hands, and all the things. So robotics is one of the very basics, and nowadays it's a happening thing which is coming. Okay. So everywhere, each and everything. Now you can see that simple hand prosthetic hand. It is robots has been doing. It is using a simple Arduino to control the 4 motors out of it. Okay. So you can see the robot has shrunk it. It is a small thing. With a gesture, one person can control. So you can see with the gestures and all this thing how drones are also controlled nowadays. Yeah. It's not up to the land, but the Arduino has gone also in the space field also. So a lot of students have, not as students and many people uses Arduino for the space projects also. So ArduSat is one of the open source platform available for students to start with a space projects. It's a 1U size satellite which has been made, and as you can see it is heavily packed with the sensors and controllers and with the transmitting. Of course the power is always provided with the battery, and the battery is charged with the solar panels in this kind of situation. So again I'm talking all this about things can be done with Arduino, and Arduino is one of the best platform to start with. And where students are going to get the experience, they want a low cost solution and to learn the things. And once they have learned, then they can definitely know the things, how the thing is operating. So when they in future they go to industry, they are aware of the system. Yes, this is how in future when they go to industry, it doesn't matter whether they are using Arduino or some other microcontroller, but at least you know the concept of it, how it is done. So it becomes even for the industry to accept the students in a very fast way. Yeah, this is Arduino. I've learned it in this thing, and industry also takes the students also in that way. Alternative, Arduino can be used for the fun purpose also. So whenever the internet is gone, you can see the game has been done automated. So a human is not using the keyboard or anything, just two sensors and one motor, it is playing the game. Okay. So we'll just go to an overview of an Arduino. What is Arduino is about? So Arduino has got a small microcontroller built in it. So microcontroller is a device which controls what are the input given to it, and it gives you some output. Now there are a lot of inputs, just like sensors. You have input sensors, or you have push buttons. You have got potentiometer. You have got keyboards. These are the various switches and all these things are the various sensors which are there. And what are the output devices? To show the output, whatever the sensor is coming, show it in a 7-segment LED indication, or to motor the start, or to indicate in a speaker form, or display something. So this is the output devices. So just take a simple example of a temperature sensor, which is an input. So it is sensing the temperature and it is displaying on a LCD display. Yeah, today's temperature is this much. Yeah, 30 degrees, 32 degrees, whatever as the temperature is, it shows as output. So you can see this is the input and that's the output for it. Okay. So a simple example. Now, if we take the same example, if the temperature becomes above 30, the motor should start. The motor, in the sense, I'll just say the AC should start, or you can say the fan should start. So this is automated. You see, you are just given an input that if the temperature starts this much, then your fan should start, your AC should start. Now this has got a more application also. Now this is program and is a manual, not a manual control, but automating control has been done. Now the future has gone beyond that. Now all this thing has come into IoT. How does IoT comes in? When the same device gets connected to an external application or an internet or something like that, then it becomes IoT, Internet of Things. So this is one thing. A temperature controller, AC, turning on the AC and all this thing is one unit. So one thing. Now you are defining from the internet, saying if the temperature becomes this much, or I'm coming to my home or something, please keep the room temperature at 28 degree. So looking at the ambience and all this thing, it will just try to check the temperature, yeah, and he will turn on the AC accordingly. So there are a lot of applications. This is a very simple example that I have talked about for the IoT also. But overall, Arduino has got something is input. The input can be analog or digital inputs. There are a lot of sensors which are analog. There are a lot of sensors which are digital also. These are the input. So you have two kinds of input, in an analog or a digital, and again the output is there. So we have a simple ID for it, Arduino ID generally it is called. So you can see you have to write the program. So these are the various things editors has got as features. Then how to set up. So you select the things and select the communication port or the USB port which has been connected, and your basic program of Arduino is written, and you're compiling the code and it is burned on your Arduino and the device starts working. So this was a traditional thing which people were doing it, and now also people do, of course, for initial setups and all this thing. This is one of the best kind, but what for this you really require an Arduino for it. But what if you don't have Arduino with you? So am I going to stop? No. In today's world, the technology is providing us advanced simulations where you really don't require Arduino with you. You have this wonderful tool developed by the FOSSI team at IIT Bombay, which it simulates Arduino on the cloud. So you can have Arduino, you can have the various sensors, as I have talked for the various sensors which are there available, output devices which are available. You just do the connection, online connection. No physical Arduino is required. You can do the simulation in the online mode, write a program online only, compile it and run it also online, and see the output. Once you are confirmed and have that confidence with the online tools, then you can definitely take actual Arduino and try to make the connections and do the actual prototyping, so that its final output can be shown for the projects or a mini projects or anything. But initially, always try to do with a simulator. Simulators helps you because it is not going to burn your Arduino, it is not going to burn any sensors or do any loss of sensors or anything. Secondly, it will help you to gain the confidence how the connection is made, how to write a program. You can multiple times you can do the changes and try to see it online only. So this is one of the best tool which I feel is available with us, and people can definitely use it. So let's dwell into the Arduino on cloud for our initial projects, and I just request you people, those people who are having laptops, computers in front of them, they can use either of this one of the website, either simulation.fossee.in or simulation.iitbx.in. So you can use one of the website to connect, and we can start our simulation. Miss, I'll just hand it over to one of my colleague. So he'll start off with the things. But before that, we start our session. I'll just we have conducted a lot of workshops with various colleges, and I'll request Pankaj from Sri Mata Vaishno Devi University, Katra, Jammu, to give an input about the workshops, what we have conducted, how it was beneficial for them also, so that you will come to know why this is important. Arduino on cloud is important for the students also. Over to you, Pankaj.
Hello. Hello, sir. Good morning. Am I audible, sir? Hello.
Yes, sir, you are audible.
Okay. Thank you very much. A very good morning to one and all. First of all, I want to put my gratitude to the FOSSEE team at IIT Bombay, who have given me the opportunity to just give a brief talk on sharing my experiences over the workshop which had been held last time in our university, entitled Arduino for Physics Experiments. Actually, this workshop was meant for our students, our faculty members, and our lab staff who are just dealing with the students on the regular basis. And the workshop was very fruitful to our students, particularly in that they were engaged in the sort of activity which they hadn't ever been earlier. Actually, I'm very much indebted to the FOSSEE team at IIT Bombay. The team members who were engaged in the workshop were Mr. Rajesh, Mr. Nagesh, Ms. Firuza, Mr. Pratik, Ms. Nirmala, and the team manager, Ms. Vinita, under the leadership of Professor Kannan Madhugirla. And it was quite fruitful in that way, and actually interesting. It was very much interesting and fun for our students, because they haven't ever interacted with any faculty member. Because the workshop which earlier went through them, they were just, you can see, just a kind of khanapurti. Just what do they do? Just give some deliberation on certain material, and they haven't had that hand-on experience earlier. And the 2 days workshop which was conducted, it was quite wonderful for all of them, for even for the faculty members even, because the team engaged the students in such a manner, in such an interactive fashion, that they were then found to be interested in carrying out such FOSSI tool, to use such FOSSI tool in future as well. Even out of this workshop, one thing I want to share, one of our students from Department of Electronic and Communication Engineering got selected for the internship, and he was very happy, and he came to me and asked that Mr. Rajesh has just asked me to congratulate you, because it is because of you this is possible. This was possible, and I was very much happy. And it is actually the kind of collaboration which took place during that workshop. The support and the kind of interest that we have received from the FOSSI team members was quite commendable. Actually, they supported me at every front, in communication, in kind of making the proposal, in just sorting out the very times when the kind of activities will take place during the 2 days. Actually, 3-4 sessions were handled each day. And out of them, our students have actually enjoyed a lot. And in future, we also just are planning to do such workshops in collaboration with the IIT Bombay, so that the further fruit and kind of interest may be drawn for these audience. And actually, I want to share some few photographs out of that workshop. Should I share, sir? Give me the privilege.
One.
Yes, yes.
Yeah,
Wait for it.
thanks.
Actually, this has rightly been said. Is my slide? Are my slides moving? I have. Hello. Hello, sir. Are my is my screen which I have shared visible?
It is visible.
Okay, okay. This has rightly been said. The connect, simulate, and innovate using Arduino. Actually, this has been realized by me particularly, and my students also in that workshop. Just we connect the device, we simulate the circuit and observe their behavior and verify their functions. And the features in the Arduino platform allow us to iterate and refine their designs without damaging the physical components. And of course, the innovation is there to develop the Arduino projects, code, and deploy and monitor them. Because Arduino provides the flexibility due to lot many things embedded within the IDE. And due to the advent of the technology, we have the availability of lot many sensors and transducers, which can allow us to perform the physics experiments. We can take out the readouts out of the physics experiments. And the interface available is quite simple. Only we have to put the setting and then loop, a kind of the event loop, which is there. That rest is very much easy. You just connect the device and that starts simulating the things. And we of course can have a lot many kind of data plotting activity. Out of this data we get, and we can plot it at our ease. And this was the workshop photograph, Arduino for Physics experiments, which was held during the very outset of this year, 18-19 January 2024. And these are the students, the workshop under progress. Students, you can see the carefully watching and adhering to the very team members who were deliberating in the details of this. You can see the workshop is under progress. Actually, we had planned to do this workshop with the physical components available, but due to the non-availability of these on the GEM portal, we could not avail this. And that's why we wholly switched the things to the Arduino on cloud. But even the students enjoyed and had the fun a lot out of it. You can see the student is working on Arduino on cloud, making out some simulation. And this is how the students also have that opportunity to interact with the team members. And they were very much happy that they can interact in the open manner. They were very shy enough to express their views and ideas. But from this workshop, they also get this thing, this kind of embedded the kind of quality to interact with the faculty members and team members. While they are in the class, they do not usually. But with this, they were quite flexible and open. And this appealed me a lot. You can see the students are asking questions, they are interacting with the team members, the professor, Kanan sir, you see interaction with the coordinator. We also had deployed one ancillary staff with us to help the students out in the technicalities. And this is how, this is another photograph which we just actually conducted during the bind-up session. We also had the press release of the same. The media also was active at that time, and we also made it public so that the people may know what is Arduino and what it can do, and in collaboration with whom. This is how I have just given you the glimpses of that workshop through these photographs. And I hope in future as well we have such fruitful sessions through workshops and such kind of activities in collaboration with FOSSI team at IIT Bombay under the leadership of Professor Kanan. Thank you, sir.
Thank you, Professor Pankaj. It was a very nice talk and insight given by you. And it was our privilege also to do the workshop with your students, and hope it was very much useful for your students, and your students are definitely using it. Thanks. Thank you.
Of course, sir. Welcome, sir. We are always at your disposal, sir. Thank you.
Thank you, sir.
Okay.
So now we'll just take it to Saima ma'am. Hello, from Maharashtra College. So from Maharashtra College of Arts, Science and Commerce. So this is the BSc and MSc college where we have conducted a workshop, and we have conducted 2 workshops with them, especially because nowadays BSc in electronics and everything, IoT, electronics and computer science, a lot of people uses Arduino for their projects. So I'll just hand over the mic to Saima ma'am. Hello, Saima ma'am.
Hello, good morning, sir.
Good morning, ma'am. Yeah, over to you.
Thank you, sir. Thank you so much. First of all, thanks to everybody, respected Rajesh sir, Kanan sir, all the team members of FOSSI and Kasim sir for, hand-holding for the workshops. So thank you so much, and also for giving this opportunity to share my experience. I can say we are very privileged that we got this opportunity to, organize the workshop with the IIT FOSSI, IIT Bombay FOSSI team, because the level of expertise that Rajesh sir and his team has, then that anybody or any other institute or any other firm would not be able to give us. So again, fortunate enough to have 2 workshops. First one that we did was for our students as well as and the second one especially was for our SY and the TY students for on Arduino. We have this subject in our SYs. The second year students have this subject, and the MSc students have this subject, wherein we have actually kits in the college. And it becomes difficult for students to practice the practicals that they have done in college at home, because nobody, like the students, cannot buy the kits. So all the options that were shown to us by Mr. Rajesh sir and Pratik That was very helpful for the students. The students are, and after that, I would like to tell you, I could not discuss it with you. We did our IoT and Arduino boot camp in the Diwali vacation. Taking that workshop, knowledge ahead, we conducted around 65 students had joined that boot camp. Our internal faculty who had attended the workshop did that boot camp, and the students enjoyed. And now what we are planning is, after the workshop, that we've given projects to students which they are making, as in some drones and some kits and some, as sir said, the agriculture thing, that plant sensors and all. And then we'll be having a competition. So this is all the result of the initiative that we took. And as I said, it is obviously it is a privilege for everyone to get connected with IIT. And IIT people coming to college, sharing the expertise is anything beyond expectation. So I hope other colleges also get this opportunity, and to work together with everyone, Rajesh sir and his team. And very thankful to Kasim sir for introducing us to IIT Bombay. Then everybody from the FOSSI, opening doors to normal. I can say I am from a conventional art science commerce college. All these privileges, entering into the IIT, collaborating with the IIT, we used to hear for engineering students and IIT itself. But then, we getting this opportunity, and for other initiatives also, not only Arduino, I'm really grateful, and I hope everybody takes the advantage, invites Rajesh sir and his team, the other FOSSI divisions, the spoken tutorial team, everybody in the college, collaborate with them, and take the most out of it. So thank you once again calling me here for sharing my experience. And from Maharashtra College, we are all very grateful and hope to continue with the other programs as well. So I hope this is the beginning, it's not an end with 2 workshops. And I hope everybody's support is with us from the IIT Bombay. Big thank you thank you for everything. Thank you so much.
Thank you, Sama ma'am, for the kind words. And definitely, we are always there for anything, queries or anything you have, and any workshop in future you want to conduct. Definitely, we are there. And I'm very, very happy to hear that you have conducted more workshops after our main workshops with the students. Your faculty has taken the interest, and they have conducted the workshops, and now the competitions and all these things are coming up. That's really very great achievements. I will say what we can, what we wanted to convey was conveyed properly.
Yes. Very much. Thank you, sir. I'll
You.
the details of the competition and we'll discuss it. Thank you so much for calling.
Thank you, ma'am. Thanks you very much. Yeah. So I'll just take to Swapna Patil, ma'am. She is HOD of Electronics and Telecom at LR Tiwari College of Engineering in Mumbai. So over to you, ma'am.
Good morning, sir. Am I audible?
Yes, ma'am, you are audible. Hello? Yes, ma'am, you are audible.
Yes. Good morning, sir. So thank you, Rajesh, sir. Good morning, everyone. It is an honor to share my experience today as the head of Electronic and Telecommunication Department at Shri LR Tiwari College at Bombay, for inviting me to speak about the impactful role of FOSSI tools, particularly on cloud, have played enhancing student project and experiment in our department. This adoption of FOSSI tool has been transformative journey for both students as well as for the faculty. So one of the greatest strength of the Arduino and the FOSSI tool is the life in accessibility. Basically, this Arduino the tool which bridge the gap between theoretical knowledge and the implementation, offering a platform to turn their innovation idea into the tangible outcome. So I just want to share a few examples of our experience. The student in our department have utilizing Arduino on cloud. What they have in the curriculum as a part of curriculum, the mini project as well as the final year also to develop project ranging from home automation system to healthcare monitoring system. This project not only demonstrated versatility of Arduino, but also like how the students are integrating academic learning with their real-time application. As a college is collaborated with IIT Bombay through Posty Club, so we have conducted one workshop, seminar on cloud, as well as we have visited to the IIT Bombay for the book launching event. So, and that event was
Sorry,
very
sorry to interrupt
excellent.
you, ma'am.
Students are very,
Hello, ma'am.
hello, yes, sir.
Can you just switch off your video because your audio is breaking a lot. It's not clear. It's showing network bandwidth is low for you.
Now, okay, now it is audible.
Yeah, it's
Am I
low.
audible?
Audible, yeah.
Okay. Now, Nartimari, our college is collaborated with the IIT Bombay through this initiative, which is Posty Club. So we have conducted the seminar on Arduino on cloud for the students, and it was very helpful for our students. We have visited IIT Bombay also for open source faculties can access, modify, and specific project needs. This culture is of sharing and innovation. Hello. Obviously, with the spirit of engineering education. So,
Ma'am, I think your audio is not clear. It's really breaking a lot.
Hello.
Okay.
Hello. Yeah. Hi.
Okay, no issues. So I think there's some issue with ma'am to connect. Hello. So I think there's some issue with the internet connection with Swapna ma'am. So let us dwell into the simulation. So I'll just hand over the mic to my colleague, Mr. Pratik Bhosle. So he will take you further for the Arduino on cloud, how Arduino on cloud can be used in your class for the projects, for the mini projects and main projects, and also in the class for the purpose. Thanks a lot. Over to you, Pratik.
हेलो खराब है
Hello. Take it on, take it. Hello. So I would like everyone to go to any of these two websites. It is basically simulation platforms for Arduino on cloud. So I have just opened it here. This is the simulation platform we are working on, the Arduino on cloud. I request those who have their laptops and those who can do the experiments, they can do along with me. And please feel free to ask any doubts if you have any. I'll be happy to answer them during my session. So that's not an issue to ask a question. Yes. So this is the simulation platform. This is the overview of the platform or the website. You can see, I'll just take a walkthrough for your understanding what components and what features we have incorporated with this website. We have a breadboard. Everyone must be knowing the components which is required for the Arduino experiments. We have an Arduino Uno as well here. Then, as Rajesh sir in his presentation mentioned about the various components and sensors. So we have output modules, input sensors over here as well. You can see we have ultrasonic sensors, a PIR sensor, then we have a gas sensor as well. So basically we can actually perform most of the experiments which we do on the hardware setup, we can actually perform here on the this simulation platform as well. The reason for this simulation platform when we developed is all the colleges must have gone through any of the issue that they might not have the hardware, or they even have the hardware, but the number of students who are actually doing the practicals are on higher side. So it is not physically possible for every student to have the hands-on activity on the platform. So basically with this simulation platform, we can every students can have the experiment. We can do the experiment, and once they're sure about that, they won't be defecting any components, and then they can do the hardware experiment as well. So as I was saying, so these are the batteries. We also have a driver IC here in a simulation, and we have a relay as well. So I would like to take one quick example, simple blink of LED. For that, I will take a breadboard out here. What you can do is, what this simulation platform offers is, you can just grab any component, click on it, and just grab it outside in this working space, and the component will appear there. So we have a breadboard. Now what we can do is, we can have a Arduino, the controller. You can see there is almost a similarity between the appearance of the every component, so student won't be having any troubles recognizing them. We can drag the LED as well. We can place it outside. I'll just connect it to the breadboard, and we will also need a resistor to limit the control, so that the LED doesn't burst. So I'll be connecting it to, let's say, pin number 12 of the Arduino. I have connected the positive pin of the LED to the pin number 12 of Arduino, as you can see. And what I can do is, I can connect this negative line to the breadboard, negative rail, and I can connect this point to the negative pin of the Arduino. So this is the simple experiment, the blink of LED. But you guys might be wondering, there is no color option, or the wires are not properly aligned. We also have that. We can change the color of the LED of the wire. You just have to select the wire, and the option comes here. So you can select different colors of these from this option. So for the sake of it, I'll be choosing red, since we have a red LED on this. And we also have this option to auto arrange the wires. So let's say you have multiple wires in the system, in the experiment, and those are not aligned. So you can just click on this option, and you will see it will ask if you want wires to be properly aligned. You can just click on yes, and you will see these are properly aligned. So you don't have to worry about the aesthetics part of it. The platform will always take care of it. You just have to make sure that you connect all the wires to the appropriate pin numbers and the components, and you can use this option and the wires will be aligned properly. For the code part, we have a code section right here on the left hand side. So you can see the void setup and void loop, the syntax of the Arduino coding. And what I'll do is I'll write the code. So you can see as I'm writing, the platform is actually giving the prompts of which command you want to write. You can just select the pin mode, and it will also tell you that this is the syntax. So you can just rest assured that you don't have to remember each and every syntax of it. The platform will always give the prompts. And since we have connected the pin to pin number 12, the LED to pin number 12, we can write pin 12 here, and we can decide the mode of it. Since it is an output component, we will write output. And in the loop section, we want the LED to be turned on. I have given the command for the LED to turn on, but if you also want that LED to be turned on for a particular amount of time, so let's say I am giving 1 second, then again I'll have to turn off the LED. And then again a delay of 1 second. So this is the simple LED program. You can see. So this is the simulation play button, where you can after writing the code, you can simulate the system, the experiment, and you will see this message. If the message appears in the green color, rest assured that the code you have written is right. If at all it happens it appears in the red color, then you may have to check your code again. So as you can see, the LED is actually blinking. For 1 second it is turning on, and for 1 second it is turning off. I would like to change the delay part as well. I can change it to, let's say, 3 seconds, and keep this as 2 seconds. Let's keep it at 1 second, so you'll be able to see the difference. I'll pause the simulation, and I'll play it again so that it takes the new values. So you can see the LED is been turned on for 3 seconds, and it is turned off for 1 second. The part which I was talking about is, suppose this is the semicolon part is the syntax of the Arduino code. Let's say if you forgot to write this semicolon, and you here show that the code is right, and you click on the start simulation button, the platform will actually tell you where the problem is. You can see it is showing there is a problem in the void loops section, and the message is clearly mentioned here, expected a semicolon before this token. So what you can do is, you can write a code, you can play on the simulation button. If the code is right, it will just play the simulation, but if the code is wrong, it will give the prompts where the code should be corrected. We also have an option, I'll just close this code section. We also have an option to save this code, let's say save this file in our system. So what we can do is, there is a option for the export JSON file. So what this JSON file consists is, it will consist the entire circuit, the code, and you can just I'll just name it blink of LED. And what I can do is I can just open it a blank page. So let's say you are starting it again, and you want to take this code blink of LED from your system, and you can see this, the circuit is actually coming again as it was designed, along with the code. The code part is also taken care of. Moving on to that, we have a gallery which have lots of ready-made circuits. You can go through this. Let's say we have a 7-segment display. We have RGB LED as well, temperature sensors, motors. We have also developed a website, a Google site actually, which have all the components. I'll just take you to it. So yeah, so this document actually helps students and the faculties to just go through the experiments one by one. As you can see, we have lots of experiments: blink of LED, control LED with push button, then let's say display scrolling text on LCD, and lots of sensors values which we can control. And we have given it in the manner where it is actually telling the aim, what all the components required. So you don't have to think which component you should be dragging in on the working area. We have also given a brief detail of the components which we'll be using in the particular experiment. We have also given the circuit that you can just take the reference from and build your own circuit. Also, we have given the code. With after that, we have actually explained line by line what the code is actually doing in the background, and what it will do with the hardware. We have also given the small GIF of the output, so you can just take the reference from and see if you are getting the same output or not. And also we are giving the assignment part as well, so that you as a user will get to know, get the realization that you have actually learned something out of a particular experiment. I'll take you back to this part. I've actually saved a few of the experiments from these Google sites. So what I will do is I'll just go here in my system. I'll take a few examples. So let's say I want to create a dice on this Arduino. So what I will do is what I have connected is I have connected the 7-segment display and a push button. So let's say virtually you are playing. All of you in the lockdown must have gone through the Ludo part, where when you click on the application, the Ludo just fumbles up and gives you a particular number from 1 to 6. So in the background, what happens is, let's say I'm starting the simulation. Okay. Yes. So this push button, what the push button will do is, it will start the Arduino, and randomly it will throw a number from 1 to 6 on this 7-segment display. So let's say it is first giving 3, and again I'm pressing, it is 5, it is 4 now. So the Arduino will generate a random number from 1 to 6, and it will just play as a electronic dice. We also have a feature where you can just zoom in to see which number you are actually connected to. So you can see all the numbers clearly. Let's say I want to go to the up and down counter. What this experiment will do is, uh, This push button will be used as for the taking the number up and displaying it, and this push button will be decreasing this number. So let's say at particular point, I'll just give you the example. You can just see this number on this 7-segment LCD. So right now I clicked on this push button, which is increasing the number. Let's say I'm going to 5, and also you can see in this serial communication block, it is showing 5. But as soon as I use this or press this push button, the number is actually decreasing. And you can also see on this window and also on the 7-segment display. Let's say we are going to the gas sensor. What gas sensor does is it detects whether there is a gas or not in the environment, and we have also written a code here. So it will just prompt it. We are connected the sensor to the A0 pin of the Arduino, and what we can do is we can start the simulation. We can move this cloud. So this cloud represents the gas sensor value, and you can see if you just come closer to the sensor, it is giving you a value. So in the hindsight, what you can do is you can just add a LED and give a condition that if the gas sensor value is above 400, which is apparently the condition right now, what you can do is you can turn on the LED or you can turn on the buzzer to get the notification that there is a gas surrounding the environment in your closed environment. We also have an option for the save temporary. So let's say I click on this, and right now it is not saved on your PC. It is saved on the local host which you're logged into. And then what you can do is you can go to the dashboard. It will ask you again whether you want to save the circuit or not. Just click on the save button, give the name gas sensor, and this is the save temporary option. What this will do is it will on your dashboard, it will create this circuit. You don't have to save it on the system. Suppose you are doing continuously, you will be working on this PC, then you can save it temporarily. If not, then you can always download the JSON file on your system and you can work it on again. This will give the access to edit the circuit, whether you want to delete it or not, or you can export the circuit as a JSON file. Let's go to few of the other. So there is a control LED with push button experiment. I'll just drag it in the center. So what this experiment is actually doing is it is defining the LED pin, which is the LED is connected to pin number 13. The button is connected to pin number 12. And only when the push button is pressed, the LED should be turning on. That is the actual working of this experiment. And we can check whether it is actually working or not. So I'm clicking on the push button and it's just turning on the LED. But you can see the LED is actually just flashing and turning it off. The reason for that is we haven't we have given the delay, but it is a delay of so small microsecond that it is not possible to sustain the actual state of the LED. So we can change the state of the delay time. Let's say change it to 3 seconds. and we can start the simulation again, and it will take the new value. So you can just press the push button. In this window, it is also showing whether the button is pressed or not. I want to ask if any of the teachers are actually trying to do, or whether they are on the simulation platform, so that if they are trying to do it and if they are facing any difficulties, I can help them out. You can just unmute your mic and ask any questions if you have any. We still have lots of experiments to go through, and I'm just taking a couple of minutes to check whether if every faculty is following, is on the same page or not. Sorry, but they can try it. No? Hmm. So let's move forward. This experiment is actually for the temperature, and we have a temperature sensor here connected to the Arduino, and we have a tricolor LED which will state, it will define, it will turn on the LED depending on the what the temperature value is. So as you can see, we have given the numbers to the red LED. It is connected to pin number 7 of the Arduino. The blue LED pin is connected to pin number 3, and green LED is connected to pin number 2. The temperature sensor, it is an analog sensor, and that's why it is connected to pin A0 of the Arduino, the analog pin. As you must be knowing, the LED part is an output device. It is showing the value, so that's why it is named as output. And the sensor, the temperature sensor, is taking the value and giving it to the Arduino. That's the reason it is saying input. And the condition which we have right now is, let's say if the temperature is below 50, then the pin number 7, which is connected to the red LED, it will turn on. If the temperature is in between 0 and 50, the blue LED will turn on. And if the temperature is below 0, then the green LED will be turned on. So we can just start the simulation, and we have this bar to define what temperature it is. So let's say I am taking it to minus. So as you can see, as the code suggested, if the temperature is below 0, the green LED will be turned on as it is. So let's take it to -1 and see if it still works. Yes. So below 0, any temperature which is below 0, the green LED will be turned on. Any temperature between 0 to 50, as soon as I cross the 0 mark plus 0 mark, it is turned blue. And as soon as I go beyond 50 degrees, the red LED is turning on. So you can do multiple options here. You can add another buzzer in the circuit, and let's say give a condition that if the temperature is below over 50, the buzzer should turn on, and that way you can play around with the components which you have here and make the experiment look quite good. This is one of the interesting experiment which we have done. It is a simple LED, the LCD experiment. In the code part, we are actually shifting the letters which are appearing on the LCD, and you can see, I'll start the simulation. You can see the words are actually shifting towards left. You can change the words as well. Let's say on the first line, you want to say innovation. And on the second line, I have written Arduino. So you can play the start the simulation button and see the updated words will be coming onto the screen. Again, similar to the temperature sensor, we have auto street light experiment where it will check the LDR value which is connected to pin A0 of the Arduino, and it will turn on the LED if the value is if the input value of the LDR is above 700. It is 780. Yeah, if it is above 780. So let's say this LDR is right now giving 300 lumens, and as soon as I go to above 780, the LED is turned on. So this is the code, this is the Arduino code which we write on this section. What you can also do is you have an option to zoom in, to zoom out. You can, if you don't want to write the entire code on the Arduino IDE, you can use this option to download the INO file of this experiment, and automate generated INO file will be saved to your system, which you can actually copy to the Arduino IDE and replicate the same experiment with the hardware. We have options of undo and redo as well, so that if you are, so suppose I'm displacing the LED and I want to reconnect it, I can redo it. I can remove this using these options. We have an option to new project if you have a system. Yeah, so this option will take you to the new page. It will be a blank page. Yes, as I mentioned, save project option is already there. If you suppose, if you want to download this image, the image of this circuit, you can use this option to download it, and it will ask you which format you want to download. Just for your reference, so suppose if you are at home as a student and you are working on it, and you don't want to carry your laptop to the your college again, you can just save this image as of the circuit, and you can replicate it in the your lab, hardware lab, on the next day in your college. Here with the component list, it will show you the number of the components which is used on this experiment, and you can download the CSV as well. So this is basically, if you have lots and lots of components and the experiment is quite bigger with multiple components, then this list gets helpful. With every component we have given at the back end, if you just click on this LDR component, this window, the pop-up window will appear, and you can just click on the view info button, and it will give a brief details of the component. It will give you the maximum power dissipation, the operations of the any particular component. So let's say I have an Arduino. You can also see the introduction of the Arduino. You have operating voltage, you have DC current per IO pins. All those informations are given in this info box. Similar to the gas sensor, we have an ultrasonic sensor, a ready-made circuit, So what you can do is you can start the simulation, and on this is a serial monitor. It will show you the actual output of the experiment. Let's say the component, any object from the ultrasonic is the distance between the object and the ultrasonic is 81 centimeter. It will give you around about the distance. You can just check it, move around, and they will the system will give you the exact reading of this distance. I have this experiment where the motion sensor is detected, and if any object is in the near vicinity, the buzzer will turn on. I'm not sure if you'll be able to hear the buzzer voice, but yes, I'll just try it. Yes, so you can see the hand is in the vicinity of the range of the sensor. As soon as you'll be seeing on the serial monitor, you'll get this message, motion detected, as soon as I move this hand. Excellent. About the Arduino website we have on the FOSSI website, Senior Rajesh Kushal will be taking over this. And if you have any other doubts, you can just post a message on the chat, and I'll be happy to answer any questions from the platform. Thank you.
Thanks, Pratik, for the wonderful session. So, hope you have got a very basic insight of what Arduino on Cloud is capable of doing, and how a person can interact with various sensors, how can write the program also. Everything is done. Yeah, definitely this is a very good examples that what we have here on Arduino on Cloud. And I'd just like to take you to the Arduino website on the FOSSIT page. So here we have a lot of things. As you have seen the Arduino, so this is a basic Arduino thing. So we have created a spoken tutorial also on Arduino, and you can where a student can learn lot of information of Arduino, from the basic of Arduino, how to connect various sensors and see the output, and then they have introduction to IoT also, how to collect the sensor data and push it to the cloud, or using the IoT sensors and IoT platforms. So this has been already demonstrated out here in the spoken tutorial, and also how to assemble a robot and how to control a robot using a Bluetooth. So as a start, students can definitely go through the series, the spoken tutorial series, and they can get more knowledge about the Arduino using the spoken tutorial also. So this series basically shows you using actual Arduino, how you are connecting the Arduino, writing the program, and seeing the output. While this platform Arduino on Cloud basically is an simulation mode where the students can learn how to connect, how to program, see the output, whatever he is trying to do it. So we have tried to show the basics, how to connect the sensors. Like now here you have the PIR sensor and sorry, motion sensor and the output. The moment any motion is sensed, the buzzer is out, buzzing. So this is the very basic experiment for the theft alarm or anything is been shown. So there are a lot of examples what I think Pratik has also displayed to you. So apart from Arduino, we have Arduino IoT GS also, Arduino on Cloud you have seen. So these are the few projects that we are going through it. So we have also have got Arduino books, specially made for how to use Arduino using Scilab, Xcos, how to program Arduino basically using Scilab, Xcos, Python, Julia, and OpenModelica. So this website provides you the books also, and if you can download the books from this particular website. It is available in the download. How to control Arduino using Scilab, program Arduino using Scilab and Xcos, how to program Arduino using Python, using Julia and OpenModelica. So all these things, books are also available. So I'll just open one of the book for your reference. So this books basically gives a very good insight of each and every experiment are basically explained in two particular format. I'll just show it. I'll just take you to that particular page and show. So it has talked about various Arduinos available, programming. These are the shield which we have made it. We have talked about. So this shield has got various sensors available on this particular thing, and it is directly put it on the Arduino itself. So here we have talked about the Arduino IDE, how to set up the program, how to set up the Scilab also, and we have tried to cover the very basic experiments with the two things. First, we have tried to cover how to program that thing in Arduino, how to load the program, and using the same program, how you are trying to do it with the Scilab also. So this and of course Xcos also, both the things have been explained out here. Similar things that you can see it in the Python book also, and Julia book also, and OpenModelic also. So we have just tried to compare how you are writing a program for the Arduino using Arduino IDE, and the same how you are achieved with the Scilab, Python, or Julia. So this is one of the very good thing that is happening. So we have another project called Electroblocks. Electroblocks is a very elementary program where students don't have to write any syntax. So they don't have to write the program. It's a block-based programs that has been explained in. So this is a running project. We'll be announcing soon about the Electroblocks. We also have Circuit.js where students and faculty can use Circuit.js, and we have created a spoken tutorial series also on it, which talks about the basics of electronics. So you can teach Ohm's law, serial parallel registers, and all this thing. And again, it shows you in a very good interactive way. So now this you can see it is showing a simple RLC circuit. So whenever I switch on, what is the output it is showing? So you can see the moment the switch is on, it is showing you the straight output. Now it is charging. Now whenever I have opened the switch, so whatever the charge it has collected, now it is showing the output on the various part. Just take a simple example of we'll just take a very simple example of a diode, say. So while teaching a diode, we are talking about, we'll say, half-wave rectifier. So here you can see what is the AC signal. So AC is coming properly, the input signals are coming, the output graph is shown, and after the output, that output is shown in a pulsating DC format. Okay, so it is in a forward bias. So now you can talk only the positive pulse of the AC signals are getting cut and all these things at the output you can see it is the negative signals are not showing because it is get cut. So now if you want to just on the live example only you have to just talk it and discuss. Now if I just swap the terminals, so now what happens? Now the negative terminal starts showing you the output on the graph. So this is a very good interactive tool that we have created, and for the same we have got a lot of sorry. For this also we have created a series of tutorials, spoken tutorials, where how circuit JS is used from creating a basic Ohm's law to serial voltage dividers, Kirchhoff's laws, everything is explained out here, and using gates also building a circuits and all the things. So this is widely used for the elementary start in electronics and for the BSc and MSc students and faculties. So I would like to interact with a few of the teachers who have joined us. Have you tried hello? Have you tried Arduino on cloud during this workshop? At least the start of a blink of LED, we are able to do it.
Yes, sir, we are able to
Please
do it, sir.
turn on your mic and speak. It is open.
Sir, namaste, sir. This is Megha from Government Polytechnic, Belgaum. Yes, sir, we are able to do it, sir.
Yeah. So, this series has got a lot of tutorials, as you can see. Definitely, you can try to create as many experiments as you want, and the series has got almost around 12 experiments. You can recreate and check it accordingly.
Yes,
So,
sir.
personally, I feel the simulation model is giving you advantage of maximum students can now use it in the online fashion mode because it's an online tool which is available, and we don't really require a Arduino for in the lab to use it. Hello. So there are good number of participants. I request please unmute and talk.
Excuse me, sir. Slide is not changing.
Yeah. Slide is not visible, sir.
I'm not sharing right now. So basically, I'm interacting with the participants and want to take the feedback where they are able to at least do few experiments on Arduino on cloud. Hello.
ఏంటి నాది ఆగిపోయింది.
అది చాట్ లో ఏమన్నా ఉన్నా కానీ క్లోజ్ అయిపోతుంది అప్పుడు.
Hello. Hello. So I'd like to show a very small video to you. Okay. Sure. Yeah. So this is one of the best and simple application that I can just show you. You can see this laser sensor that is showing you. And one more part I'd like to show you is do it. So this is a simple physics experiment what they have just tried to show it. And of course, again, this is also using Arduino. They're using. So Arduino will give you exact timings of when the ball hits the sensor. So you can see what time it has reached and all the things. So in various experiments, whether it's mechanical based, electronic based, so Arduino definitely use a lot of sensors and people can definitely achieve the outputs. So this is one of the simple physics experiment. And of course, these are the various experiments that have been already shared with you. Just go through some of the things. So this is a basic robotic arm which is shown in the demonstration, and how a dummy is programming the robot arm, actual robot arm. You can see how his work done. Putting it to a person object. So now you have shown him a basic. We'll run the same program again and again. All the and to kickstart the very first thing, I personally encourage everybody to use Arduino on cloud and do your first experiment using Arduino on cloud. And once you get the confidence of connecting various sensors and everything on the cloud, doing the coding also, seeing the output of whatever you have decided, and then switch it to the actual Arduino. So I'd like to get some more info feedback from the participants. Please unmute your mic and speak. I'm stopping my sharing out here. Please unmute your mic. Hello.
Good morning, sir.
Good morning.
I am Dr. A. N. Doraivel from King's Engineering College, Tamil Nadu, Chennai.
Yes, sir.
Yes. Today we got a very good input from your side, sir. So usually our students are doing in hardware modules. Now we came to know that this can be simulated in system itself. So we can give these inputs to our students. They can utilize very much and they can gain knowledge on this. We will establish in this method of simulation techniques in our college. Thank you, sir.
Thank you. That's what I have in my talk. I was talking that very first step, the students should use the simulation mode. So you're not putting any harm or you're breaking or you're making short of Arduino and all this thing. So whatever the first experience is everything on the simulation mode. And then once the students gain the experience, then they can definitely switch to the actual hardware and try to do their projects. Yeah.
Yes, sir. Yes, sir.
Anyone else? Thanks. Thank you, sir. I'd like to receive more feedbacks from the participants.
Sir, thank you so much for the nice session, sir. Sir, can you tell me the person who is working with VLSI, sir?
Hello?
Hello? Hello?
Yes, yes.
Sir, this is Santa Lakshmi from SDN Vaishnav College, sir.
Yes.
Really, it was an excellent session, sir. Sir, I have one question, sir. I need a person who is working with VLSI, very large scale integration.
Yes. So for the VLSI, we have one more session, not a session, but a separate thing called as eSIM.
Mm.
The FOSSI is also promoting eSIM, so which is an EDA tool, and it has got a provision of the designing the chips and simulation part in that also.
Mm. Where can I get the course, sir, for this VLSI?
So
Course. Is there
actually,
any course to
so
do?
basically we don't have as such. I think my colleague Vinita will be able to talk more on it. So she is just having her session right away after my session.
Okay, sir.
And if you can discuss, just hold on. I can just hand over the mic to Vinita.
Hello.
Hello.
So very good evening to everyone.
Good evening, ma'am.
Sorry, good afternoon. I'm so sorry, not good evening. Hello.
Yes, ma'am.
Just 1
Good
minute.
afternoon,
There's
ma'am.
some issue over here. Just 1 minute. Okay, is my voice better now? Yeah.
Yes.
Yeah, we can hear you, Vinita.
Okay, thank you so much. So for VLSI, actually, eSIM is a software for design and simulation of electronic circuit. So, and we have a part of PCB design also in that, where you can actually fabricate, do a PCB designing and electronic simulation circuits also you can design and simulate. So, a part of VLSI, I will say, not completely. So we do have spoken tutorials on eSIM. As you all are subscribed college, you can see the spoken tutorials on eSIM. eSIM is the software. Okay.
Okay, ma'am.
Yeah, I would.
Ma'am, can you give me a contact number or any other mail ID
Sure,
or
sure. I
something
will
else?
just share my screen.
Okay, ma'am.
And I'll show you the website right away. You can go to esim.fossey.in. It is esim.fossey.in. Chat पे भी डाल
Ma'am, screen is not visible, ma'am.
Oh, it's not visible. Just 1 minute. Is it visible now?
Yeah, it's coming.
So
eSIM.
here you can see we have esim.fossey.in. So you go to resources.
Resources.
Yeah. So here you can find the GitHub repository. We also
Okay.
have spoken tutorials here.
Okay, ma'am.
You can download eSIM from that repository. Then you go to spoken tutorial. Okay, you click on eSIM and then you can see the spoken tutorials on eSIM. Tutorials. It's taking time to load. Yeah. So we have about 16 spoken tutorials on eSIM. Okay, here you can see PCB layout, laying tracks. Okay, mapping footprints. So all this you can do, even circuit schematic simulation. All this you can use using you can do using eSIM. Okay, so this is one software which is being developed from scratch at IIT Bombay, and it is free and open source. So you can refer the tutorials. There are 16 tutorials. If you have any issue, you can write to us at contact-esim@fossey.in. We also have a Slack channel which you can join. And of course, there are forums. You can ask your queries on spoken tutorial forums if they are related to tutorials. Okay. So, yeah, we have some. So we here have done very interesting things. Since I have come on this website, I would like to show you that we have conducted many competitions, maybe a hackathon kind of thing, which we term as marathon here in eSIM, because hackathon is all about coding. But here we have actually designed circuits. So we have conducted 3 such marathons, I will say, in eSIM. So first one was just basic creating the circuit simulation. It can be digital, analog, and or mix of both, and they had to use Skywater PDK. So here we have got lots of circuits, and we did this for all the students and who are interested, and we got about 138 circuits which are good. We got lots of submissions, but out of which 138 were the good submissions. Then we did mixed mode signal simulation marathon. Okay, so here also they had to create something in eSIM, and they had to present it to us. So here also we have got about many 63 circuits, because this was little higher level, and here the level increases as we go on. And then we have a mixed signal using Skywater PDK. So here also we had some completed circuits. So more than 100 circuits you can see we have got. So all this is available. The good part about this is, I will tell you, is the university name comes, and even the person who has submitted this has come, and what work they have done you can easily click here and see. So this actually becomes the advantage for the students, whoever has participated in this and become successful. So from by participating in these kind of workshops, they have actually gained lots of benefits. If you see, they have placed in good companies, and they have gone for higher studies abroad, where they have used this link where they showcase their work, and their name is appearing on the website along with the university name. So it's uh, a good thing for a university to be proud of, that their students are representing their university, their college, and the work done is freely available. So they can, and this is for lifetime. This link is not going to change anywhere, and it's not going to be gone. So they directly use, so this becomes a proof of their contribution actually. So this very helps them in job opportunities and career for higher studies. So this is very good. So in 2025 also, we'll be coming up with these kind of hackathons, and we'll let you know about this. So marathon is what we call in eSIM. Okay, in downloads you can find the latest version of the software where you can download. Okay, and whenever you are stuck, we are there to help you. So contact -esim@fossee.in is what you write. So this is what we have for VLSI.
Thank you so much, ma'am. I have any doubt, I'll call you, ma'am, or I'll contact through the mail ID, ma'am.
Okay, thank you.
Thank you so much for your reply, ma'am.
Stop share here. So also I would like to tell you about Fossee project. Fossee works on free and open source software, and we have just a hello, yeah. So Fossee is something which works on free and open source software on education, and we promote open source software. We have created various spoken tutorials for you all to refer. So for example, eSIM was there, and then we have conducted Arduino also. So you all can refer those spoken tutorials and do. So more about Fossee, maybe our principal investigator, Professor Kannan Modkalya, is here. He can put more insights on this. Sir, over to you.
Vinita, just check the textbook companion thing. Scilab textbook companion, that's not running.
Okay, sir. I'll check. Yeah.
Good afternoon, everyone.
Good afternoon, sir.
I see more than 200 people joined. Really happy to have all of you. And you all know about, I guess, spoken tutorial. What do I see? I see this going upside down. Okay. So this is Dr. Santana Lakshmi. I can see your video.
Yes, sir.
So you are in which college, Dr. Santana Lakshmi?
I am from SDNB Vaishnav College, sir, Kompet, Chennai.
Okay, Vaishnav College. Okay.
Vaishnav College.
That's near the airport, right? Not too
Yes,
far.
sir. Yes, sir.
Right. Very nice. Okay, so I can also see Akanksha here. She will talk about spoken tutorial. I will talk about, I'll just give an overview of the FOSSI project. And there were questions that I think Vinita was already answering. Are there any other questions that we need to answer before I get started? Okay. Okay.
Questions? If there are any questions, I can take it later.
Yeah.
Please go ahead.
So let me just give, let me open, yes. I'm trying to share my screen. I'm trying to share my screen. So, okay. Can you see my screen?
Yes, sir, it's visible.
Okay. So this is our website, fossee.in. Fossee, you can actually see it here, FOSSEE.in. And there are many different things that we promote. For example, we promote Scilab, Python, eSIM. eSIM is an electronic circuit design software. And you can access it further. For example, OSDAC, DWSIM, OpenFOAM. Scilab, if you, so it says Scilab. If I click this, it'll take me to the Scilab website. And on the left side, you see various things, case study project, XCOS textbook companion project, Scilab textbook companion project, lab migration project, FOSSEE Scilab toolbox. Some of them are especially suitable for faculty members. For example, if you see, I'm still in Scilab. Click this lab migration project. It starts by saying, are you still buying expensive licenses of computational tools? And then so on and so forth. And then the lab migration team helps in the following ways. Okay. And the lab migration project expands now. It says procedure, coding guidelines, completed labs. If I click this, then you see that who are the different people who have created, for example, right? This is Government College of Engineering, Erode, Digital Signal Processing, the year 2023. This is Vivekananda Education Society, Institute of Technology. This is in Mumbai. Feedback Control Lab Practices 2020. This is Srinidhi Institute of Science and Technology, Finance Calculations, so on and so forth, right? Lakshmi Institute of Technology, Control Systems Engineering, Shreyas Institute of Engineering and Technology, Analog Communications, and so on. This is Sardar Patel Institute of Technology, Image and Video Processing. So if you click this, it'll actually tell you what they have done and who did this. Dr. Sujata Kulkarni. What is the title of the lab? Electronics and Telecommunication Engineering. That's the department, university. And look at this. This is a unique link. Okay. So this is Dr. Sujata Kulkarni can use this URL anywhere, wherever she wants. One can, of course, lab, if you download, it'll download a entire directory structure, folder structure, which will have all the subfolders, it'll have all the programs. You can also download the PDF, which I will click now because you'll be able to see it here. Let me just see. Okay, there it is. Right? So there it is. You can actually see that, and you can see list of Scilab solutions to implement different transforms on a given image, to study and perform spatial frequency domain image enhancement techniques. If you click this, it'll take you to the code. Okay. So going back to, you can of course save it and so on. So I went to Scilab. In Scilab, I went to this lab migration project, completed labs. Of course, we also have labs in progress. That list, there are only 3 that are in progress. So this is a way to showcase the work that you might be doing in your college or university through the FOSSEE portal to the entire world. Okay, that is something I thought I'll point out. And I come back here. So that is Scilab. So through every one of them, you can reach. For example, if you click DWSIM, DWSIM is an alternative to Aspen Plus. Flow sheeting. Flow sheeting is a study of solving such chemical plants. Okay, simulation of such chemical plants. Here we have something called, let me see, flow sheeting project. This is what I wanted to show you. Underneath this, you have completed flow sheets. So if you click this, it shows 270 flow sheets done by students across the world, I would say. For example, here it is Rajkot. This is Bhatnagar University of Mute. This is Marwadi University, Rajkot, IIT Madras. This from Tehran. And this is from Ecuador, and so on. Many students have contributed from Ecuador. Your students are also welcome. In case any of you have chemical engineering, you're welcome to do that. We have open forum for computation fluid dynamics. In fact, tomorrow there is a workshop that we are organizing on open forum. Open model, like PLC is another thing, hardware thing that may be of interest. Arduino related things are available through here, FLOSS Arduino. Okay. So it has a wealth of information. What I will do is now I will go to a set of slides that I have already created. I'll quickly go through this. The focus being collaborative content through students. Actually, I should have said through students and faculty whom we train. Okay. Because I told you the lab migration is done by mostly faculty members, right? And the website links are here on the bottom, as you can see. Okay, we just do this, see what happens. You can see the, we move it here. Not sure whether you keep it here. Yeah, you can see the links here, right? FOSSEE.in, spoken-tutorial.org. So let me quickly go through this. FOSSEE came from FOSS. Normally we say FOSS, okay? But then there is a question. Let me just, yeah. FOSS means what? Free and open source software. So the word free, does it denote freedom or free of cost? Okay. It turns out that we denote freedom. Freedom is a higher concept. Okay. And how do we distinguish? How do we say that we mean freedom? You add this word liber. Liber means freedom in French. So that's why the moment you put this L, it becomes floss. You can think of floss as same as FOSS with an L inserted. And then this is for education. So in fact, I should have called it FLOSSY, but then I had already coined the word FOSSEE, created a logo, registered it, been using it. So we decided not to change the logo. The ministry also knows us the FOSSEE project. So we decided not to change it to FLOSSY. Otherwise, I would have called it FLOSSY, right? It turns out that a large number of national projects are FLOSS-based, whether it is Aadhaar, UPI, CoWIN, etc. In fact, almost every one of the large projects are open source based. Let me just briefly go through this work done by FOSSEE. These are some of the software we promote and what areas they work on. And this is the equivalent between commercial software and FLOSS software. We already talked about MATLAB and Scilab, SPSS and R, things like, of course, Arduino is open source, so there is no problem. Scilab is something, it's an alternative to MATLAB. Many of you might be using it. What I'm going to do is, I'm going to talk to you about, Scilab is, of course, very reliable. People are using it. CNES is a French equivalent of our ISRO. They launch Ariane rockets, and they have placed many of our satellites. And CNES uses Scilab. If I click this, it'll show you. Okay, in CNES, they are using Scilab. So if CNES that launches GSAT satellite can place our Ariane rockets places our satellites using Scilab calculations, you can very well use Scilab. Okay. And then here is a Scilab textbook companion that students from across the country have contributed. What do? The students give Scilab code for, they'll first learn using spoken tutorial, and then they give Scilab code for solved examples. Remember, important thing, solved examples, not unsolved, not difficult problems, easy ones. Standard textbooks, the FOSSEE team verifies and then uploads, gives certificates and honoraria. The code gets uploaded onto the FOSSEE portal. So in the early days, we even gave honorarium. Students have solved 1 lakh examples using, that is, they have given Scilab code for 1 lakh examples. Available here for the entire world. One can go and check it. Let me come back to this. In the meantime, let me see if I can give a demo. Okay, something is happening. So let me go back here. Maybe towards the end, if I can get it running. But let's go and see here. You can see this 633 books. These are the books available. So you can choose different subjects.
Sir, I will show if at the end possible. Right now they are looking into the problem.
Okay, you can give a demo of that. So you can choose aerospace, computer science, chemical engineering, chemistry, electrical engineering. Let's take electrical engineering. And in that, let's choose signal processing, DSP. Now, if you see, what is the book I'm looking for? You can see almost all the well-known books. I'm looking at this Procus. You know, it's a standard book, right? So you can see who created it, about the contributor, Senthil Kumar created, and then you can download the PDF if you want. You can download the code from there. Vinita, you have to check this also. Okay, some of the books come as access denied. Okay.
Sure, sir. I'll think it requires some login. I will check, sir.
No, it should not have any login required. Ask Vishal to check, go through every one of them.
Yes,
Make
sir. I'll do
all
that.
of them and ask them to.
Sure.
It's actually disturbing.
Yeah.
Okay, I can choose some other thing. It is not that case. Let's take this. Whether this also has the same problem. Okay, maybe this entire series is not okay. Okay, this we did. Where did I do that? I went from here, right? Here. And then let's take this. Thermal physics by this. Okay, so we seem to have a problem on the entire site. So we'll get it fixed. This one, Benita will give a demo of. Vinitha, what I want is, I want somebody to write a program which monitors, makes sure that things are working. I thought we had this thing at one time. Why we have discontinued? Okay, because it's
We
embarrassing.
are
to have
upgrading the website and moving it to new
all the
services.
links.
Yeah,
All the links should be working. Okay.
We'll fix it, sir.
Yeah. Okay, so I'm going to skip this also. So we do textbook companions for other software. Also, not just Scilab, Python, OpenModelica, R, and so on and so forth. Then we do lab migration by college teachers. This I already showed you. MATLAB to Scilab, Aspen Plus to DWSim, so on and so forth. Okay.
Sir, you can show the cloud demo if you want.
No, I'm not going to show that. You
Okay.
can do that.
Okay, sir. Thanks.
So I wanted to talk to you about CFD. This is a very interesting thing because I want to show you that we are not doing just, let's say, Scilab, MATLAB kind of a thing. We are working in different areas. Here is computational fluid dynamics. Dr. Kalam was before he became the president, he was in charge of the Agni missile. He took the Agni missile to Berlin. He was going to do wind tunnel testing. He found that CFD, well, actually, he was denied. Berlin people asked him to come. Previous night, they told him, sorry, we can't do this for you because somebody told me not to do it. Then he found that computational fluid dynamics could also do it. In order to do this, you required supercomputers. Those were also denied. Then Professor Deshpande made the algorithm to work faster, 10 times faster. Ordinary computers were sufficient because he made it work a lot faster, better algorithm. Then what he did was he tested it, it was successful. He came to be known as the missile man. And OpenFOAM is an open source software. It is used extensively by BARC, ISRO, and DRDO labs. So going back, let's go to fuzzy side. So I gave a demo of some of these things. Okay. Now about Arduino, they would have shown a lot of things. So these are all some things that came out of OpenFOAM. eSIM is an electronic circuit design software. This is also another area in which you may be able to contribute. We can do mixed signal simulation using design and simulation using eSIM. It's an alternative to Cadence, PSpice, and things like that. eSIM on cloud is there. It's accessible from here. So if some of these things, because I'm exceeding time, so Vinitha may be able to give a demo if some of the things have not been done before. We have 500 electronic circuits created by students. One can actually see this here. You can see 358 are here, circuits. You can download each of them and run it on eSIM. Here, completed PSpice to KiCad circuits. That means these were originally in PSpice and who converted them, things like that. So those are here. And then LTSpice to KiCad circuits, once again. So you can see that there are more than 500 circuits available here. And somebody who worked on it with us went to do masters in North Carolina State University in the field of computer engineering. I told you about chemical engineering. This I already showed you. Arduino Uno you would have already seen. Okay. These are some of the activities in a nutshell. So I'm going to stop here. And are there any questions?
If there are any questions, please unmute and talk. About FOSSI, if you want to know anything more. Okay, so we are getting chats as no, sir.
We also take FOSSEE interns and fellows. Okay, that is an extremely popular one. Now you're all from spoken tutorial subscribing colleges, so you have an advantage now. Our team is the FOSSEE team is ready to help you. We generally announce because the next semester-long internship is going to happen. We'll start from I think we take students from January sometime or maybe February, right? And then there will be a screening task. We don't select on the basis of the rank of a college, rank of a student, your accreditation level. We don't look at any of those. We only take students who are capable of contributing to our project, which in return gets shared with the public. As a result, your students end up contributing something to the society, and they also get known. And through them, the college gets known, the college teachers get known, right? So how do we do it? If I go by rank, if I go by mark, how do I know that person is capable of solving my problem? I have a project which I want to complete so that I can release it to the community. How do I know that? So we give a screening task. We give a screening task and say whoever can solve this problem is welcome. Now, how to solve the screening task? We conduct some sessions. Those are all done free of cost. Okay. And now that you are a subscribing college, if you want some extra help in this, you can always talk to your coordinator. That coordinator will talk to Vinita, one of the managers, Usha, Payal, one of our managers, and they will make sure that you get the help. Okay. So in that sense, you know how to contact. You have spoken tutorial coordinators, and they will be able to help. By the way, we are, you all know that I have retired from IIT. I'm now an emeritus fellow. In order to provide continuity to this activity, I'm forming a company called Edu Pyramids. Edu stands for education. Pyramids, because I believe in attainable pyramids. I think I have a slide here. Okay, I do have fellowship. Let me quickly go through this. I'll skip all this. This I have already told you. Why do students contribute? Certificates, honoraria, URL of their work. Many have benefited. This is what I said, pyramid of excellence. So people do more and more difficult things and climb to the top of the pyramid. But even as they go up, they can be placed anywhere in the world. Okay. But I believe that these pyramids should be attainable. It should be accessible to everybody. I should not say I will take only top 1% based on some test. It should be more based on their performance. So we give a screening task. We say for our selection, we say, you are given 2 weeks. You learned this, solve this, come to me. If you need any help, I'm willing to help you. That way I find motivated people. I also give enough time for people to demonstrate. So that's what for me, pyramid is extremely important. I call it as attainable pyramid. These are all attainable pyramids. So we believe that through this company, we will create a lot of attainable pyramids. Okay. And by the way, I wrote an article on JEE. It came in Indian Express yesterday, opinion page. In case you see it, you might have seen it on my LinkedIn page. I announced it, but you might also see it in. So there I talked about how JEE should become an inclusive thing. It should be modified. I believe that the JEE we have right now is very bad. Okay. I'm going to stop here now. I think are the pyramids attainable? Yeah, this is very important. This is what I'm saying. There are no limits at any level. No limits. Everybody will say, if only I had done a little more work, I would have gone to the next level. Everybody will try. The whole pyramid will get lifted. So I'm going to stop here and hand over to Akanksha. Sorry, I have taken your time, but you can take your time. Okay.
Thank you, sir.
Hello. Hello.
Can I start the
Hello, Akanksha. Your voice is feeble.
Yes.
Yes. So I'll just
Is it audible now?
yeah. So everyone knows Akanksha. She doesn't need any introduction because everyone is a subscribed college. So she is the national coordinator of spoken tutorial team, and uh, she has attained lots of uh, MOUs and letter of association with you all. So yeah, we really want to thank Akanksha, and I'll be covering that in my next bit. So Akanksha, please take your time. There's no hard and fast. Okay. Thanks. Bye.
It is. I'm really happy to address all of you. And on this workshop, Arduino on Cloud, this is an awareness program. And so,
Akanksha,
and I know.
hello.
Yes.
Akanksha, your
Yes.
voice is coming and going. I think you should switch off your video and then.
Okay. Is it audible now? Is it okay?
Yeah, it's clear, but when you talk, it's breaking in between. So switch off your video and talk.
Okay. I have done it now. I think
It's
if it is
better.
okay.
Better.
Yeah, it is better now. Thank you. So yes, I was telling that most of you have already adopted spoken tutorial training program for your students, and many faculty members also have done many of the courses, because we really believe that, because you all really want that your students use ICT, smart classroom techniques, and become smarter, right? And also like they will be more confident, enhance their future. And if talk about the college, university, that your image improving NAC reviews and the placements. So today in the next 15-20 minutes or so, I will explain to you about let me share slides. I will quickly go through these and will say what we are going to talk about today, and it's really important. So let me share and just write in the chat box if you are able to see my screen. Are you able to see this? Hello?
Yes, we are able to see it.
Yes, ma'am. Yes, ma'am.
Okay. Okay, so today, so spoken tutorial project IIT Bombay. It is developed at IIT Bombay and established with funding from Ministry of Education, Government of India. So today, what I am going to talk about is 21st century learning design and spoken tutorial IIT Bombay, because you know how it is important today to just not only having that traditional mode of learning and what are expected skills, it is important how spoken tutorial can help you to achieve those skills. So what are the objectives? First is the learning environments in 21st century and the core set of expected skills. According to the World Economic Forum, they mention few top skills that is important and it's needed to have for the young learners to survive in this increasingly complex world with with the changing technology day by day. And the second is we will discuss the framework for learning in 21st century, that is an innovating teaching learning practices, and then spoken tutorial IIT Bombay. So growing up in this world of today, so what do our children learn, what tools do they have, and how they are trying to make a sense of the world around them. So just think, like, just an example, your mobile phone for an instance, like how much do you depend on that and have these tools changed the way you live, how we communicate to our colleagues, how we communicate to our family, right? So if these tools are having such an impact on how we live our lives, perhaps it is time for us as educators to consider what learning environments are needed in 21st century. So let's move to the next slide. So we as educators are in a unique position, we all, and shape the world as we have in our care for the future generation. Many governments around the world are also beginning to realize that education is central to helping society to meet these, with help and meet these challenges with globally connected all. For us, like Mandela most famously said that the education is the most powerful weapon which you can use to change the world. So thinking about the skills required to learn, live and work in our globally connected society, let's think about our young learners who are in our education system today. Are they being well prepared for the world they live in as an adult? And looking ahead, then we need to ask ourselves, what is the future of education? And can we answer this young learner when they ask this question, like how it is going to support my education? Are we ready for that? And it is becoming increasingly urgent for us to design an education to equip them to thrive in an increasingly complex world, a world full of challenges that we don't know like how to solve today. The rate of change is so fast that nobody knows how to solve that exactly today. And at the same time, our education system in general are rooted in models that were successful in the past for some students, but maybe they are too facing the stress of the changing work and lives around them. So let's move to the next slide. There have been a number of framework developed, as I mentioned, and it's as per the World Economic Forum. They mentioned few top skills that has to be there, that and they really feel that is required. The core set of expected skills include being knowledgeable about the world, thinking outside the box, being smarter about the sourcing information, having good people skill and ability to solve problems, and finally, being able to work as a part of a team and ultimately to become a lifelong learner is essential to being able to live and work in this globally connected and complex world. The reality through is that today's classroom has not changed at all at that much. We know that smart boards have replaced whiteboards and which replaced chalkboards, but we are still in that mode of uh, close to that airplane experience where teacher is there lecturing students and students are hearing, teacher is delivering content, and which may not be relevant to their current or future lives, and then testing what is there, what they delivered. So it may sound judgmental, but and many we criticize the system for not keeping with the times, but at large it is there, and they are also trying to cope up with the constant rate of change. And it also reflect that what changes need to be made to the education system in order to ensure that future generation can cope effectively with this rapid pace of change. and be able to learn constantly throughout a lifetime. So let's move to the next slide. So why it is so important? So see, just see, this little girl is off to school with her backpack on her back. If she could get all the words information into one backpack, by the time she graduates, she would need 64 backpacks, right? And at the same time, consider the fact that the amount of information in the world is doubling every 2 years, right? So it is so important. So these young learners, our future generation, is so important. And in 17 years, say for in 17 years or before that, she will have most likely graduated and be in a career we don't even know that career will be. And because it most likely hasn't been invented, right? And it is clear that she will need to know information and have skills, but it is also critical that she will need to be a deep lifelong learner. It is very important. So these points are the crux of 21st century skills debate. In particular, the type of learning environment that are necessary to develop the skill set. Let's move to the next slide. So this is P21 framework for learning in the 21st century. And it has been, I'll just give a little overview of this. It has been developed with the inputs from teachers, education experts, and business leaders to define these skills and the knowledge students need to succeed in the work, life, and of course the citizenship globally. So this is the rainbow arc represent the student outcome and the pool is the support system. So in the rainbow arc, if we talk about the green color, where the core subjects are mentioned, core subjects we already know that our see, which includes our English, reading, language, mathematics, or it can be a foreign language also. So this is one. Above the green arc, this is the yellow one, learning and innovative skills. That is 4 C's, which includes critical thinking, communication, collaboration, and creativity. So this is so important that you should have these skills to survive with this rapid change of happening in today's education and the technology that is changing day by day. And to the right of the green arc are information, media, and technology skills, often referred to as ICT literacy. We all know that if we talk about spoken tutorial, information and communication technology, so is the ability to use technology to develop 21st century content knowledge and skills in support of 21st century teaching and learning. To the left is life and career skills, where it comes good teachers, right, have always incorporated life skills into their pedagogies. The challenges today is to incorporate these essential skills into colleges, schools, and strategically on board actually. So what are these? As example, if I mention leadership, ethics, accountability, adaptability, so all these really very important. And of course, beneath the arc are what are referred to as the pool or the support system. So let's move to the next slide. So the research shows that what is important in innovating teaching practices, student-centered pedagogies, extending learning, and embedding ICT. So here, student-centered pedagogies means the learning is personalized and collaborative with this, where students can do the knowledge construction with high level of self-regulation, where the learning is there 24 into 7, So there is no a time bound, timeline is there. And also there are, yes, 24/7 learning opportunities are there. And also the learner is able to connect globally, and they are able to understand those, the cultural understanding. He or she is able to understand. At the same time, it is through ICT and be able to understand by the educator and by student. Let's move to the next one. So as I was talking about spoken tutorial, I was talking about ICT, also the MOOC, massive open online courses. So if talk about MOOC, we all know that we can go up to masses. Like if it's not only in a class, if we are just going to train 30 students, we can train to 1000 to up to 1 lakh students by adopting MOOCs. And spoken tutorial is a Google award winning MOOCs program for IT training. MOOCs, offline MOOC, I will say it's an offline MOOC. And it's a successful IT training program for more than a decade. And to date, we have trained more than 86 lakh students and teachers across the country. It includes all engineering colleges, polytechnics, ITI, etc. And it is guarantee of obtaining mastery through self-learning. As I mentioned earlier, in the 21st century, skills to be needed, a deep lifelong learner. So self-learning is very important. Even if a student is learning right now, doing BTech or BSc, BCom, is pursuing for a higher studies, going for PhD, self-learning plays an important role. And if talk about the flexibility learning at spoken tutorial, it's they can learn anytime. Online, offline learning is possible. And like if talk about the fulfills the requirement to learn offline MOOC courses, spoken tutorial comes in. So it is a snapshot. If we check the number of learners trained, it's 86 lakh plus that we have trained till date. And it's keep changing on our website. And the number of colleges that we are right now working is 6,000 plus, and the knowledge partner to 125 affiliating university, and more than 15 state government higher education and technical bodies nationwide we are working with. State bodies where we can just reach out to maximum colleges and the learner in the state. For example, we are working with CC Telangana, we are working with DT Gujarat, we are working with DT Haryana, DT Himachal Pradesh, and there are many more that we are working with, where we are able to reach out to many colleges. DT, where maximum polytechnics are, we are able to cover. And I'm sure today is the workshop on Arduino, and it is so useful course for the polytechnic student. So I will recommend all teachers here that all the polytechnic students must do Arduino course, so that students can get that confidence. Of course, they can learn it, get the certificate, and also the mastery in this course. So what is spoken tutorial? I know all of you know what is spoken tutorial, but if many new uh, colleges are here, or the faculty members, they can have an idea what is spoken tutorial. So it is an 8 to 10 minutes audio video tool that teaches open source software. As Professor Kannan has already very nicely explained what is open source software, that it's freely available, freedom to for the source, freedom to modify the code. So this is open source software, and we do through the active learning method. Students learn any software in short simple steps. So what is the active learning method? So basically we use our senses. We do have 5 senses. So when a student is hearing, it's audio, like hearing, using ear, watching, eyes, and the same time practices on the keyboard, that touch. So they are using that, and so it's that makes it an active learning method. They can replicate the instruction and build their own program side by side. What is side by side method? So in the left side, the tutorial is there, spoken tutorial, where they are watching that audio, video, that particular module. The right side, software is there. It is open source, so you can download it. So, and at the same time you are hearing it, you are practicing at the right side and getting the output. So that is called side by side method. The best part is that we do offer our courses in 22 different regional languages. So if any student or the learner is comfortable learning any course in their local language, they can do it. Later, if they do it in English, that will improve their English communication also. So let's see few examples for e-governance and FOSS. So if talk about Kerala, the very first state, Kerala in country, where 100% e-governance application, close to 26 schools and 1.5 millions are using Linux. Maharashtra using Linux and LibreOffice to revamp its healthcare system. Also, the Tamil Nadu government IT department has issued an order for mandatory installation of Linux in all departments. Maharashtra government police headquarters and the election office also has saved rupees 90 crore because of FOSS and has used that money to purchase computers. So how, see how effective and beneficial it is for colleges and the state governments. So why spoken tutorial for students? So I'll quickly go through. It is really important. So lab related courses to enhance their academic performance. Students can use that to increase their performance for any practical course, because we focus on practical than theory. Let me give you one example from one of the college where professor told me that one student was struggling with Java course to learn basic Java, was not able to clear the makeup exam, and the professor recommended him that you should go through spoken tutorial Java course, learn it, and then come back. He has given him all the downloaded the course given to him, and he was able to do it. And then after a few days, he told that he mentioned that he was able to clear his basic concept of Java using spoken tutorial, and also able to clear the exam. So it is really important for all the lab related courses. I'll start with C, C++, starting from the first year, for Java, Python, all the courses. Then comes to lucrative open source software, Python, Drupal, etc. The industries are looking for those are skill trained in Python, Drupal, so they can learn. Students can learn through spoken tutorial, anytime, anywhere. As I already mentioned, this is user friendly, side by side method. So it's like a home tutor. Study offline, you can complete the course at your home also. No internet is required. Once the course is downloaded, no internet is required. We do have a technical forum where if any student is facing problem, they can pose their questions on our technical forum. An expert from IIT Bombay will answer that. We do have a job recommendation portal also, right? So if students will score well, they will be eligible to participate in job fair organized by Spoken Tutorial IIT Bombay. So next, move to the next slide. Why Spoken Tutorial for faculties? Faculty development program, as many are here also. So you can also do, and if you are our academic partners, if you have already joined this program, faculty development programs are free for the faculty members. So again, you can do it anytime, anywhere, no fixed timing. You'll also get certificate from Spoken Tutorial IIT Bombay. You will get the downloaded content for lifetime, e-resource for teaching. And this is accepted by the MOOCs program and recommended by AICTE and some. You can use this for career enhancement also. I will give an example for the LaTeX course, that is specialized for technical writing training workshop, for thesis, lecture, notes, books, etc. So you can do the LaTeX faculty development program, and if you can conduct that also in your whole college and inviting other faculty members to be a part of it, for that also we will give you letter of appreciation as a faculty organizer, because you have conducted it for other faculty members also. And if talk about the spoken tutorial, yes, ICT tools, introduction in classroom, animation, graphic tools use. If anybody is teaching those like Blender and all that, you can use as ICT tool. Let's come to why spoken tutorial for college. It is very important, as I mentioned in the beginning, to improve image for NAC placements, etc. So we do give a letter of association with Spoken Tutorial IIT Bombay. If you are academic partner with us, it can help to improve your NAC, NIRF, and NBA rating, and we can suggest, because in many of the criteria Spoken Tutorial can easily fits in. It's through a distance learning mode, and all the lab courses can be mapped in lab hours. As I mentioned, it helps to improve performance of students for the lab related courses. Letter of certification for the overall performance for whole year, what student, how many trainings have been conducted, what if the other courses have been done, other what the seminar, webinar in association with Spoken Tutorial have been conducted. Everything we can give in the end of the year to the college. Flexibility in training and test, and I always emphasize it on the flexibility. It's as per your convenience, you conduct the training, as per your convenience, you conduct the faculty development program, and also the test. So it is whenever the college is ready, when the students batch is ready, you can conduct the test. So there is no timing that this time you have to conduct the tests. Whenever you feel convenient and the students are ready, you can conduct the test. 24/7 service provided by Spoken Tutorial. We do have training managers for each and every state. So the best managers are there to support you, and if any difficulty issue you face, you can immediately call them, and they will solve that. And introduction of smart class technology in the college. So you can do that using Spoken Tutorial. Very first thing, that first step, how a college can start. You just have to nominate 1 or 2 faculty as the organizer per college. This is for a new college, and if already subscribed colleges here, and if 1 or 2 department is only doing it, I will recommend that you should cover maximum departments, so that maximum students can get this opportunity, and they can learn many courses, because it's not only for the computer science department, even art and science students and can also do our courses. Those faculty will register on Spoken Tutorial website and will get their membership login ID, and this is for lifetime. Enroll students and start with 1 training session for a batch. Very easy, just 1 training session for 1 semester, and it is easily done. The further training session that are which course, for which stream, for which department, for the next academic semester, the training manager will help you by filling calendar, or will help to make a planner for you. Of course, the constant guidance will on each and every step will be there. Yes. So earlier I mentioned lab courses, then I mentioned lucrative job courses. So I want to mention few that organization, the industry where these, the courses, the certificate can be useful. So job skills with Spoken Tutorial courses. If talk about Drupal, PHP, MySQL, so students can get job as web developer, database management for Android app, for GIMP Inkspace. Students or learners, can apply and get jobs in graphics and design, in textile, paper, poster, etc. All these industry. Blender course, the animation industry, you know that you have heard that movie Life of Pi, Jungle Book, all these have been using, made using these software. So students can get jobs in animation industry. Then C Java Net beats IT industry. Our very famous DW Sim course in processing industry like detergent and pharma manufacturing plants. Then Linux, Boss Linux in e-governance, MEC, SMEs, government, military. As I mentioned earlier, I have given you the example for e-governance in Kerala, Maharashtra, Tamil Nadu. So there is the maximum chance that learners can get jobs. Then it comes to Linux for system admins. Uh, they can have the and LibreOffice that is equivalent to MS Office. As I was explaining, the proprietary software and the open source, LibreOffice is equivalent to MS Office. So this is free. LibreOffice is free. That can be used for the document, for spreadsheet slides, and the students can get jobs in data entry, desktop publishing, magazine, and newspaper, etc. So as I mentioned earlier, the art and science students from the very basic, they can start with LibreOffice, because each and every student nowadays need that basic IT skills, like how to make a presentation, how to create a table, so it is very important. So from a very introduction to computer and the LibreOffice for the art and science, uh, colleges can start learning. So these were the courses. These are few more courses, like from basic IT skills, graphic to the from graphic animation to the programming languages, for web development, database management, and to the specialty package for technical writing, also for chemistry helpers also, and the specialty package like Scilab, LaTeX. I always recommend that the faculty members to do LaTeX and Scilab. It is really important for them. And we are going to launch our winters semester faculty development program, where you can all do these courses and get the certificate from Spoken Tutorial IIT Bombay. So please have a look. So these are the courses. We have many more. So once you decide to join, we will explain. And once you decide to train more and more department, we will explain and we will map all these courses as per your stream, as per your department. So I think I'm end of my talk. So as I told you earlier, that please think, and if you are ready to join, if you want to conduct faculty development program, these are my contact details. You can write, and if any question, you please ask. Thank you so much.
Thank you, Akanksha.
So these are my contact details. You please note down, and you please write to me, and we will reach out to you and will help you. Just stop sharing.
Thank you, Akanksha. It was a informative talk. So I hope everyone has written down your contact details. Yeah. So I realized that I have never introduced myself. I was just talking to everyone. So I'm Vinita Parmar. I work as a senior project manager at FOSSI team. I want to give a small demo, which Kanan sir couldn't, because we have some, we are actually shifting and upgrading our website. So that website was down. So sir was giving one demo. This is actually very interesting to see. And like we have Arduino on cloud, we have Scilab on cloud. So you go to cloud.scilab.in. So this is something which we have created, where there is a list of departments. You see aeronautical, civil, industrial, mechanical, chemical, then chemistry, economics, computers, electrical engineering, and allied fields, mathematics. So basically, these are the textbooks which sir was showing you, textbook companion project. These are the departments where the textbooks have been contributed. Then we go to subcategory. I have selected electrical engineering because I am from electronics department myself. So I'm choosing control systems here. You can choose any. Okay, but I'm choosing control systems here. Then I'm using something which we have used when we were doing engineering. So I'm using automatic control systems by BC Co, and I'm choosing frequency domain analysis, and this is the example. Like in this chapter, in this book, these are the chapters which have been coded in Scilab, and in this chapter, these are the examples which are coded in Scilab. So I select Bode plot because it is well known to everyone. Then I click on execute, I get the output. So this is the graph of this code. Okay, you can download it. I am closing it right now, and this is the output. So this is what it is. But as you see, this is the uh, interactive interface where you can change the values. You can make this, and then when I click execute, it will again show me a different graph, and even the values change here. Okay, so this is something which you can use in your classrooms for teaching Scilab. Okay, so that is what we wanted to show you, and we have similar things for eSIM on cloud also we have. So as we have done Arduino on cloud workshop for you all, we might do eSIM on cloud soon. And then we have R on cloud, which is still in the development phase. I see there are many, while I was going through the registration page, I saw that there are many non-technical people also. So we have Soul and Focal for you all. So Soul basically has something related to maths and science. So it has JMOL, it has Chem Collective, Avogadro, Free Plane, GeoGebra. So you can explore this website and get more details on it. Then I go to Focal. Focal is all about animation and creating infographics in 2D, 3D. So like Akanksha mentioned about Inkscape, Blender, GIMP, Inkscape, Synfig. So we do lots of competitions also using these softwares. So what you have to do is just keep checking our website, fossey.in. We keep announcing. So if you go to events, you see we have done lots of events, and now we will announce our right now winter internship is going on. We'll announce semester long internships soon. So these are our last year semester long interns. You can see the name of the intern, the institute name, and the work done. They have actually submitted the report and what project they have worked on. So you can see he was our Scilab intern. He has worked on developing a toolbox on signal processing. Then we have Devyani, who has done on the case study project of Scilab. Then in eSIM, we have digital and mixed mode circuits. Namira Jabi, she has worked. So all these people actually have worked and they have benefited a lot. So soon we'll be announcing our semester long internship and summer fellowship. Right now, winter internships is going on. So this is the format. How do you participate? Basically, you just have to register, and then we'll have a list of this is the screening task where you can test your skills. And once you click on view, you will see the elaborated form of the screening task. This is something which you have to do, and submit it to us before the dates. We give around 15-20 days time to submit this. But even in this, if you have a problem, as Kanan sir mentioned, here we have our contact details on contact email ID. Our mentors will definitely help you and will guide you on how to submit if you are stuck somewhere. Okay, so this is all we had for today, and I would like to express a vote of thanks formally to thank everyone here. I'll just stop sharing my screen. Yeah. Yeah. So, firstly, I want to thank everyone on behalf of FOSSI IIT Bombay that you all have spent, you have come all the way since morning and you have given your time. Okay. A special thanks to all the faculty members for accepting our invitation and for being there with us today, patiently listening to what we have. I would like thank you everyone for participating, and I thank our firstly thank our principal investigator, Professor Kanan Modgalia, for supporting and guiding us. He always inspires to do us good work and conduct these kinds of workshop. So thank you, sir. I would also like to express my heartfelt gratitude to the spoken tutorial team, without which this wouldn't have been happened. I really thank Akanksha and her team for putting in so much effort and making this event successful. So thank you, Akanksha, and the whole spoken tutorial team for supporting us. My sincere thanks to our managers, our senior managers, Ms. Usha Vishwanathan and Mr. Rajesh Kushalkar, sir. Uh, you have actually started the session and warmed up with the faculty members, and you have given a good start to this event, and thank you for supporting. I would also like to thank our team members of the Arduino team, Pratik's. Actually, both team members' name are Pratik, so I would like to thank both of them, and thank you for conducting the wonderful hands-on session for today. I would also like to thank the eStudio team, this recording, Zoom meeting, YouTube live, everything they have been done. So thank you, the studio team, for always supporting us. And finally, I would like to thank IIT Bombay and Ministry of Education for supporting with us. And I thank you everyone for being here. And I would like to tell you that we'll have similar sessions. So please be in touch and keep checking our website. Thank you once again. Bye.